Welcome to this explainer. Today, we're diving into what is arguably the holy grail of cross-platform development. We're tackling the massive, honestly headache-inducing complexities of mobile and desktop media handling. Specifically, we'll look at how the B4X MediaChooser component abstracts all that mess away, so you can just write your media code once and capture seamlessly anywhere.
So if you've spent any time building apps, you know the pain I'm talking about. How in the world do we avoid writing three completely different apps when every single operating system has its own wildly different camera APIs, totally unique file systems, and super aggressive memory management? You just want a button that takes a picture, right? But under the hood, Android, iOS, and Windows are speaking entirely different languages when it comes to hardware access.
Well, this is exactly where the MediaChooser comes in. You can really think of it as your universal translator. It's a B4X class component designed to orchestrate all of this elegantly behind the scenes. Basically, it abstracts away those complex OS-specific media handling routines and permissions into a single, clean, unified code base. You ask for a photo, and the MediaChooser just figures out the local politics of the operating system to get it done for you.
All right, here's our roadmap for today. First, the MediaChooser solution. Then, building the user interface. Next, Android intents and services. Then we'll look at iOS camera integration, followed by desktop file choosing for B4J, and finally, we'll go under the hood with MIME types.
Okay, let's jump straight into Section 1, the MediaChooser solution. Before we get bogged down in platform specifics, let's look at what this abstraction actually gives us right out of the box. When you initialize MediaChooser, it immediately gets to work managing your file system. Instead of you manually handling fragmented file structures, it automatically creates a temporary folder, cleverly named MediaChooser Temp, right in your default directory. But it doesn't just leave a mess behind. On initialization, it runs a routine to clean up and delete any old temporary files starting with that prefix. And even better, when a capture is finished, it hands you a clean MediaChooser result custom object. This neat little package gives you a success boolean, the directory, the file name, and the MIME type, so there's no guessing and no parsing file paths manually. Moving on to Section 2, building the user interface.
What's really fascinating here is how simple the UI code looks compared to the hidden iceberg of platform-specific code underneath it all. Look at this workflow for a camera button click in B4X pages. First, you check runtime permissions. Then, using the wait_for keyword, you literally just call chooser.captureImage. The code basically pauses right here without blocking the main thread, waiting for the user to snap the photo. Once it returns our MediaChooser result, we verify the success flag, and if it's true, we just load the bitmap right into our image preview. 4 simple steps. No callback spaghetti, no nested delegates. Just a seamless, synchronous-looking flow for an inherently asynchronous task.
Which brings us to Section 3, Android intents and foreground services.
If you've ever developed for Android, you know it involves constantly battling highly aggressive memory management. It's a classic trap, really. You fire at intent to open the native camera app. The camera app is heavy, it needs RAM. So standard Android behavior is to ruthlessly kill your background app to free up that memory. You take the picture, but when you return, your app is restarted and the photo data is just gone. Well, the MediaChooser solution here is honestly brilliant. It uses a keep running service. Right before firing the camera, it starts the service as a foreground service with a low-importance notification. This essentially gives your app a VIP pass, telling the Android OS, hey, I'm doing something important here, please do not kill me.
By combining that foreground service with an Ion event listener, which bridges into Java's Ion action result, we can safely fire off the Android camera intent, survive the memory purge while the camera is actually open, and catch the resulting image data exactly where we left off. It even throws in a quick sleep loop just to perfectly time the service startup before launching the camera. It's pretty smart.
Next up, Section 4, iOS permissions and camera integration.
Let's talk about iOS. Apple has its own famously strict protocols for hardware access, right? Well, MediaChooser handles those strict authorization gates up front. If authorization is denied, it immediately raises an error event, so your app doesn't just crash out of nowhere. It interacts natively with the camera objects, and when it gets a photo, it writes the raw bitmap stream directly into that MediaChooser temp folder as a JPEG. But here is my absolute favorite detail. Apple's photo library picker has some really quirky behaviors, particularly when dealing with GIFs. Sometimes it returns a URL starting with a file:// prefix, which completely breaks standard file operations. MediaChooser quietly sanitizes this. It uses a substring method to strip those 7 characters right off before handing the result back to you. It's handling all those OS-specific headaches so you don't have to.
All right, Section 5, desktop file choosing with B4J.
Now, for a bit of a funny reality check when you bring mobile assumptions into a desktop environment using B4J. This perfectly illustrates the hardware differences between the platforms. On mobile, we just assume a camera is always there. But if you call capture image or capture video on a B4J desktop app, MediaChooser literally just returns a not supported error event. On a desktop, MediaChooser acts strictly as a file selection tool. It wraps the native file chooser and applies specific extension filters for your images or videos. What this does is ensure your cross-platform code compiles and runs perfectly safely on desktop, even if the hardware paradigms don't exactly line up.
And finally, Section 6, Under the Hood with MIME types.
For our final technical deep dive, let's look at how the MediaChooser actually figures out exactly what kind of file you just selected. Because let's face it, relying on file extensions is kind of a rookie mistake. They can easily be renamed or missing entirely. To ensure total accuracy, MediaChooser uses a function called detectImageMime. It takes the file, ensures it is at least 4 bytes large, and then opens an input stream to read literally just the first 4 bytes of raw data into a byte array. Then, it checks those raw bytes against specific hexadecimal magic numbers. So, if the first byte is 0FF and the second is 0D8, it instantly knows, beyond a shadow of a doubt, that it's dealing with a JPEG and returns image/JPEG. If the first 3 bytes match 0x47, 0x49, and 0x46, boom, it identifies a GIF. And if it can't match these magic numbers at all, it just provides a safe fallback of image/star. This clever little trick allows your app to handle media types with absolute confidence, entirely independent of whatever the file name claims to be.
By mastering components like the MediaChooser, you're really freeing yourself from the exhausting work of constantly fighting the operating system. You get to focus your energy on building actual great features for your users. We've seen how it tames Android's memory management, seamlessly navigates iOS permissions, and totally unifies desktop file picking. So the question I want to leave you with is this. Now that you've seen the power of this kind of abstraction, what complex, messy OS feature are you going to abstract next in your own projects? Thanks so much for joining me on this explainer, and happy coding!